Hello and welcome back to my channel. This is Donald Siami, author of Hidden Mathematical Genius Within Revealed. Today we are looking at calculus, and it is a continuation on differentiation. So this is just application of differentiation. Okay, so we are told to find the equation of a tangent to the curve y is equal to x cubed minus 5x squared plus 8x minus 4 at x is equal to 1. So first thing, you need to know that equation of the tangent is given by the form y minus y1 is equal to m in brackets x minus x1, where x1 and y1 are just the coordinates of the points, okay, where this tangent lie, and m is the gradient, okay. And what we should always remember is that gradient is just the derivative of the curve. So we just need to differentiate the curve, the equation of the function there, then we substitute 1 for x. Okay, so we start. We have y is equal to x cubed minus 5x squared plus 8x minus 4. So we need to find gradient, which is just m, which is also equal to dy dx. That is the derivative of y with respect to x. So the derivative of x cubed, we know that it will be 3x squared. That is 3 multiplied by 1 is 3. Then the power will reduce it by 1, so you get 3x squared. Minus the 2, you multiply by 5, that is 10. Then the power there will reduce it by 1, so you just get 10x. Then the derivative of 8x is just 8. Okay, derivative of 8x, we just get rid of the variable x there, so we remain with plus 8. Then derivative of a constant is just a 0, so we just get rid of that minus 4. Okay, so this is the function for gradient, and we are told that it is at x is equal to 1. So therefore m is equal to, so where there is x we put a 1. So we have 3x squared, that is 1 squared, minus 10, then multiplied by 1, then plus 8. So m is equal to 1 squared is 1, multiplied by 3 you get 3, minus 10 multiplied by 1 is just 10, then plus 8. So we have 3 minus 10, you get a minus 7, and minus 7 plus 8, you get 1. So gradient is just 1. So the other thing is that we need the point, the coordinates of the point, that is the x coordinate and the y coordinate. So we already have the x coordinate. We know that x is 1. So we also need the coordinate for y. Okay, so the coordinate for y, you just put a 1 where there is x. So we are going to have, there it's 1 cubed, that is 1, minus 1 squared is 1 multiplied by 5, that is 5. Then 8 multiplied by 1 is just 8, and minus 4. So we get y is equal to, so we have, that is 1 minus 4, that is minus 4. Minus 4 plus 8, you get minus 4 plus 8, you get 4, and 4 minus 4, that is a 0, meaning y is 0 and x is 1. So you substitute from the equation there. So y minus y1, that is y is 0, so y minus 0 is equal to 1. Then in brackets we have x minus, and we know that x is 1. Okay, so y minus 1, that is just y, is equal to, okay, 1 multiplied by x is x, and 1 multiplied by minus 1 is just minus 1. So therefore, the equation of the tangent is just y is equal to x minus 1. Okay, we go to question 2. Question 2, find the equation of the normal to the curve, that is y is equal to x squared minus 3x minus 4 at the point 2 comma negative 6. Okay, so here it is equation of the normal. So equation of the normal, the form is y minus y1 is equal to, so for the equation of the normal, where we're supposed to have a gradient, that is m, we're supposed to have 1 negative 1 over m, that is negative 1 over gradient. Then in brackets we have x minus x1. So that is the form for equation of the normal. Okay, so from here we need to find gradient. Okay, so gradient you just differentiate. So the function there is y is equal to x squared minus 3x minus 4. Okay, so you say m is equal to, that is dy dx is equal to the derivative of x squared will be 2 multiplied by 1 is 2, then the power reduced by 1, so you get 2x. Okay, so that is just 2x. Then minus derivative of 3x, there, since there is just a single variable, you just get rid of the variable. So derivative of 3x with respect to x is just 3, so we have minus 3. And derivative of a constant is a 0. Okay, so this is the gradient function, that is 2x minus 3. Okay, so therefore m is equal to, from the point, the x value there is 2. So you just substitute, where there is x we put a 2. So we have 2 and 2 there, minus 3. So we have m is equal to, so this is 2 multiplied by 2, you get 4, then minus 3. And again, 4 minus 3, you get 1. So gradient is equal to 1. Then we go back to our form, that is equation form of the normal, equation of the normal. So it's y minus y1 is equal to minus 1 over m, then x minus x1. Okay, so we know that the point is 2 comma negative 6, 2 comma negative 6, meaning x is 2 and y is negative 6. So we have y minus, so y is negative 6, so we're going to have minus the negative 6 is equal to minus 1 over m is 1, so over 1. Then in brackets we have x minus, the x value is 2, so x minus 2. Okay, so here we have minus and minus. Negative multiplied by negative, you get positive. So we are going to have y plus 6 is equal to negative 1 divided by 1, that is negative 1. So in brackets we have x minus 2. Then you multiply through there. So we'll say minus 1 multiplied by x, you get minus x. Minus 1 multiplied by minus 2, you get positive 2, that is plus 2. Okay, then we can try to rearrange the terms. The minus x can come this side, so here it's minus, this side it will be a plus. So we are going to have y plus x is equal to the plus 6 here, this side will be minus 6, so we are going to have 2 minus 6. So we are going to have y plus x is equal to 2 minus 6, you get minus 4. So that is the equation of the normal. That is y plus x is equal to minus 4. Okay, so when you are told to find the equation of the tangent, the equation form is y minus y1 is equal to m in brackets x minus x1. And when you are answering for equation of the normal, the equation form is y minus y1 is equal to minus 1 over m in brackets x minus x1. So this is how you perform calculations to do with tangent of equation of the normal and equation of the tangent. Thank you so much for your time.